Here we have example 22.1. So I'm going to walk through the summary of the information. So we have the utility function is equal to the log of C, which is the consumption that the individual chooses, whether that be in period 1 or period 2. Their income in period 1 is certain, and they'll get $10. Their income in period 2 is uncertain. So they have a half probability to earn 8, and another half probability to earn 12. So here's where we want to set up their expected lifetime utility, and that's what we're trying to maximize here. So we're going to get both their log of their consumption in period 1, which is equal to their earnings in period 1 minus their savings from period 1, plus the expected consumption, or the consumption in period 2, which is based off the expected earnings in period 2. So this is where we'd get 1/2 log of the earnings in period 2, if they are the high earnings, plus S, plus 1/2 log of the earnings in period 2, if they're the low earnings, plus S. All right, and now we're assuming here that we don't have interest rates at this time or discount rates for simplicity. So now that we have this, let's go ahead and plug in the numbers. So we get the log of 10 minus S. 10 is our earnings in period 1. Now plus 1/2 log of, we'll get, 8 is not our high earnings. Our high earnings are going to be 12 plus the savings, plus 1/2 log of our low earnings, 8 plus S. And now that we have that, we can maximize this with respect to S. So let's choose our savings rate that will maximize our expected lifetime utility. So now we're going to get 1 over 10 minus S times -1 plus 1 over 2, 12 plus S, plus 1 over 2, 8 plus S, equals 0. If we look at this, this is our Euler equation. Here is our consumption in period 1, or our marginal utility in period 1, and here's our marginal utility in period 2. Right? And so this is C1, U prime, C2. And those are going to equal each other because we have the -1 right here, so bring it to the other side. And so that's our Euler equation. But now, rather than focus on the Euler equation, let's go ahead and solve this out. So we're going to set up our Euler equation just like we had, but we're going to go 1 over 10 minus S is equal to 1 over 2, 12 plus S, plus 1 over 2, 8 plus S. Now we're going to get common denominators. So over here on this side, we're going to get 16 plus 2S plus 24 plus 2S, and that's all going to be over 16 plus 2S times 24 plus 2S. So we get this number here and multiply it by this number, top and bottom, to get a common denominator. We get 1 over 10 minus S. Okay, now we multiply these out, so we can add these together and multiply that out. We get 16 plus 2S times 24 plus 2S is equal to 10 minus S times 40 plus 4S. Now we're going to have to solve for S. So as we solve for S, let's multiply these out. So here we get 384 plus 48S plus 32S plus 4S squared is equal to 400 minus 40s plus 40s minus 4s squared. Now we're going to collect like terms, and we'll end up getting, as we bring these all over, we'll get 8s squared plus 80s minus 16 equals 0. We're going to factor out at 8. S squared plus 10s minus 2 equals 0. Now we use the quadratic equation, which we all know, sung to the tune of Pop Goes the Weasel. Negative b plus or minus the square root of b squared all over, or minus 4ac all over 2a. If that didn't catch it, that's great. You can use Excel here. You can use your calculator. You can use the quadratic equation. If we get this, we get s is equal to 1.962 and s is equal to negative 10.1962. So therefore, this will be our optimal savings rate. So we'll save about 20% of our income in period 1 to be able to smooth out our consumption between period 1 and 2 so that we have maximized our expected lifetime.